we go back to the general tab here in terms of other types of loads that we can put on the vessel. These are probably the main ones that we've done so far. Certainly all of the masses are going to be important, and you want to get your masses as accurate as possible. The closer your mass distribution is to reality and your structure is, the better. With that large mass distribution, when you're artificially pushing weight in a certain direction, it's like you can overload pieces of the structure. We've already gone through, I guess, all of the types of mass distribution at this point. The point forces you typically aren't going to be using unless there's a very specific load in a given direction, although something like that beam that we created originally, that sample little beam, it's not a floating structure. You'd have to apply some type of load to it, which would most likely just be a point force at the end. The different types of pressures, I haven't used any of these. They're described in the help file. I hate to spend a lot of time going over something that you're probably not going to use. I would have to look up how to use these things because I haven't used them much. Plate linear pressure, I think, varies the pressure from one side of the plate to the other. Surface head, I think, is based on distance from the water surface. Don't recall what the surface zero, I think you can specify where the surface should be for that one. Additional beam was one of these two, either additional beam or edge was for side loading, I think, a beam. But the one you may use is design pressure. What design pressure will do is when you load your model and you've got all of the normal loads from the tanks, trochoidal wave or whatever else, or specified bending moment, you're evaluating the hull girder structure. But you may have additional requirements for pressures on the different regions of the ship, whether it's an additional pressure on the hull plating from an additional slamming load, or deck plating pressure requirements for a cargo area, or for office space, berthing space, passageways, and so forth. Any of these may have specific requirements for a design pressure in addition to just the general hull girder load, and that's what this is for. You can specify areas where you're going to put an additional pressure on there, and what this will do is it creates a new submodel. It essentially will allow you to solve the global model, and this new submodel is essentially like a fine mesh model. Basically, it'll create a new sort of submodel for each evaluation patch in there, and apply the design pressure to the evaluation patch using the deformations and everything, all the boundary conditions from your global model solution. Because you wouldn't want to apply the design pressures as part of the loading on your global model. Like if you were to apply all of these deck pressures and the slamming pressures and every possible pressure load to all of your panels and all of the other loads, it's just not a realistic requirement. So what it'll do is you put whatever your standard hull girder load is, you see what your loads on the vessel are, and then you apply on a piece by piece basis just this design pressure evaluation on a small submodel.